This is a fantastic question. First thing to do, actually, when I did this, I used non-right angle trigonometry. So I'm going to explain how we can do it without that first of all, and then I'll go over how I did it. So what we can do is split the triangle into two right angle triangles. This is really useful because now I've got on the left a 60 degrees, 90 degrees, and 30 degrees triangle. And on the right, that means this is going to be 45, and this is 90, so this is 45. Hence an isosceles triangle. Okay, now I'm going to label this length x. And what this means is actually we've got half of an equilateral triangle, and this length will be 2x. If you're less happy with that, then we can write down that cos 60 is equal to x over the hypotenuse. So the hypotenuse is equal to x over cos 60, which is a half, which gives us 2x that way. So 2x. Okay, and then the height is going to be 2. I won't write the height, but it's going to be 2x all squared minus x squared square rooted using Pythagoras' theorem on this blue triangle that I'm outlining. And that's going to give me root 4x squared minus x squared, or root 3x squared, or root 3x. Okay, brilliant. So the height is root 3x. Now that is actually very, very useful because if you, well, this must also be root 3x because it's an isosceles triangle. And as the caterpillar creeps down the stairs, that's how much it's going along. It's going along root 3x. And it's also going down root 3x. So overall, the caterpillar to go from B to C is going to be 2 lots of root 3x. And to go from A to B is 2x. We had here, so we can cancel out the x's and we can cancel out the 2's. So we're going to be left with root 3 to 1. Really nice. Now I didn't see to split it into two, so I'm going to show you the more complicated way that I did it, and that is to use non-right angle trigonometry. So I'm going to call this side x, and the slope here, the dotted line, y. This angle is 45, and then using the sine rule, you can write down x over sine 45 is equal to y over sine 60. Using knowledge of exact values of trig, I'm not going to derive these here. I get x over 1 over root 2 is equal to y over root 3 over 2, which means root 2x is going to equal 2 over root 3y. Okay, I could then divide by root 2 actually to give me x equals 2 over root 6y. So at least I've got a relationship between x and y now in terms of x. Okay, let's think about y. So like I did with my first explanation, I can actually imagine um, to go along the stairs, I'm actually going all the way along here and then down. So if that is y, this is actually going to be y over root 2. This is worth knowing, by the way, when you have an isosceles triangle with 45 degrees, which this is. That is going to be 45 and that's going to be 45. You get some y over root 2. Because you can see when you use Pythagoras' theorem, I'm going to get y squared over 2 plus y squared over 2. That is just y squared. So when you square root it, you get back to y. If you're less happy with that, then you could call it something. You could call it like question mark, and it's going to be question mark squared plus question mark squared is equal to y squared. So 2 question mark squared is equal to y squared. And then we can square root to see that y is equal to root 2 question mark. So question mark is y over root 2. Okay, I've kind of done Pythagoras' theorem really quickly there. So what that means is that the stairs, or the length, is going to be 2 times y over root 2, which is actually going to be root 2y. But then I know that I've got x equal, okay, it's probably best to leave it like that. So I've got root 2y, and then over here, because I made x the subject, I've got 2 over root 6y. So let's compare these. So this, for the stairs, it's root 2y. And then for the length, it is 2 over root 6y. So I can cancel out the y's. I'm going to multiply through, I think, by... Remember, this was root... Okay, I forgot that. This is root 3, root 2. So I'm going to times through by that. I'm going to get root 3 times root 2 times root 2 to 2. Can cancel these out, and I'm back to having root 3 to 1. You know, it's not as neat for sure, but it works. It uses a few other ideas like exact values of trig and that isosceles triangle, but it gets the job done. You know, so two solid methods. Like the first one the most. You know, really neat, I think. Great question, like I said. I hope you enjoyed it.